Hi everyone, here are your 6.2 part 2 notes. So in the beginning of section 6.2 we just got into factoring trinomials. We factored trinomials with leading coefficients of 1, we factored trinomials with leading coefficients other than 1, and we factored trinomials with multiple variables, and we factored trinomials with leading coefficient with a negative. So now what we're going to get into is factoring by substitution. I like to call this U substitution just because U is a uncommon variable that is used in any type of algebraic equation. So that's why we just kind of pick U. So what you can do is you can simplify an equation such as we have here to something that looks more familiar to us. So we have 2 times the quantity of x plus 3 squared plus 5 times the quantity of x plus 3 minus 12. Now just watch. Just watch. Don't do anything. Don't write this down. What you could technically do is you could expand that x plus 3 squared to x squared plus 6x plus 9, and then multiply that by 2 to get 2x squared plus 12x plus 18. My 5 distributes to 5x plus 15, and then minus 12. And then I could combine all my like terms, which would get me, what, 17x. 15 minus 12 is 3 plus 18. Yep, plus 18. What did I just say? 3 plus 18 is 21. And then we have that trinomial, which we then could factor. 2 times 21 is 42. Find factors of 42 to get you to 7x, right? So you could do it that way. But the purpose of this course is to be able to work smarter, not harder. So if we do a U substitution, so this is what I do want you to write down in your notes. I'm going to let U represent the algebraic expression. I'm always going to look off of this middle term because that's going to be my key here. I'm going to let U represent x plus 3, which means that this whole trinomial will now turn into 2. Now instead of x plus 3 here, I'm going to make that a U squared plus 5 times, now instead of that x plus 3, I'm going to make that u minus 12. Now I have a pretty simple looking trinomial to factor. So I'm going to go ahead and factor that. So I'm going to do 2 times negative 12, which is negative 24. Factors of negative 24 that get me to positive 5 would be 8 and negative 3. Put over my leading coefficient of 2. Reduce, 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 right? Always reduce. So that goes to 4 over 1, negative 3 over 2. And my variable in this case is u. So now we get the binomial of u plus 4, and we get a binomial of 2u minus 3. But I'm not done because we substituted x plus 3 in place of u. So now I'm going to put that u, or that x plus 3, in place of u there and in place of here. So instead of u, we just said before that u was really x plus 3. Now I'm going to bring down that plus 4. So that simplifies to x plus 7. And then here I'm going to substitute my x plus 3 back in place of u. Bring down my minus 3. Distributing that gets me 2x plus 6 minus 3, which is going to simplify to 2x minus or plus 3. 6 minus 3 is positive 3. And then there we have our answer. Okay, so 2x squared plus 14x plus 3x is 17x plus 21, which, if I remember correctly, is the trinomial that we had when I did my expansion of the original problem. Okay, so the U substitution makes it a little bit easier because you're not going to make any errors with your expansion, and when you do expand it, you're going to be left with bigger numbers to have to factor. So this way it keeps it a little bit more simplified. So let's go ahead and do another one like this. So I'm going to let u represent what's inside my parentheses, which in this case is x plus 5. So let u equal x plus 5. All right, so now I have 8u squared minus 2u minus 3. So we can factor that. 8 times negative 3 is negative 24. Factors of negative 24 that get us to 2 would be 6 and 4 with the negative on the 6. My leading coefficient is 8. Reduce, 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 reduce. Don't forget to reduce. So that goes to negative 3 over 4 and 1/2. My u goes with the denominator. So this factors to 4u minus 3 and 2u plus 1. Put your x plus 5 back in, so 4 times x plus 5 minus 3. That goes to 4x plus 20 minus 3, which would be 4x plus 17. And then over here we have 2 times x plus 5 plus 1, which would go to 2x plus 10 plus 1, which is 2x plus 11. So there it is. Much more simple, right? Okay, so let's do another one. Ooh, this one looks a little crazy. So inside my parentheses, I have an r minus s, I have an s minus r, and I have an r minus s. So my goal is, can I get everything inside my parentheses to be the same? So here I have an r minus s, and here I have an r minus s. How can I get that middle set of parentheses to also be an r minus s? Well, right here, my r is positive, my s is negative. Right now my r is negative and my s is positive. So I need those to be opposite in sign. So how do I make something opposite in sign? We just take out a negative 1. If I take out a negative 1, that would make my r become a positive and my s become a negative. But I now have to multiply this negative 1 with that negative 5. So really that's going to become a plus 5rs times r minus s minus 6s times r minus s. And r squared times r minus s. Okay, so we got some options here. We can let u represent r minus s. So now that becomes r squared u, or just ur squared, I guess, plus 5rsu minus 6su. Well, what does each of these terms have in common? They each have a u, so let's pull that u out by factoring it out. So we now have u times r squared plus 5rs minus 6s. Can I factor that trinomial inside? Sure. 1 times negative 6 is negative 6. Factors of negative 6, that get you to positive 5. 6 and negative 1 over 1. I have an r here. And that should be, I think I have a typo on this one. I feel like that should be an s squared, and it should be, that needs to be an s squared back in that original problem. There we go. So then we're going to put s here. So now we get 1r minus 6s and 1r minus 1s with my u out in front. But what did our u represent? Our u represented r minus s. So now I have r minus s times r minus 6s times r minus s. Can I simplify that any further? Yeah. I've got 2 r minus s's. So really, isn't that just the same as r minus s squared? Yeah, it is. Times r minus 6s. So that would be your final answer. That's a good one. That's going to be similar to your problem number 57 that you're going to do out of the textbook here shortly. So hold on to that one for when you need to reference it. Okay, so now let's get away from when we have a binomial representing our u, and what would happen if we had something smaller than that. So for this u substitution, what we're going to do is we're going to focus in on, we're going to focus in on the middle term. So my middle term is y squared. So I'm going to let u equal y squared. So now this turns into 6u squared, because remember, y squared squared is the same as y to the 4th. So that's going to force my first term to just be a u squared, plus 7u minus 20. Now factor that as normal. 6 times negative 20 is negative 120. Factors of 120, that get us to 7. Let's see, 4 and 30 is a no-go. 120 and 5 and 24 does not get me 7, so let's go higher. 6 and 20, getting closer. 8 and 15, I think we have it right there. I'm going to make the 8 be the negative, put it over 6, reducing that gets us -4/3 and 5/2. All right, so this factors to 3u minus 4, 2u plus 5. And so then what did we say u originally was? Y squared. So 3y squared minus 4, 2y squared plus 5. And there would be our final answer in factored form. So you can check it. 3y squared times 2y squared is 6y to the 4th. My middle gets me -8y squared plus 15y squared, which is 7y squared, and then we get a -20. All right, next one. Ooh, here we got all sorts of craziness happening. So we've got a to the 6th power, we got a to the 3rd b, and then we got a b squared happening. All right, so if we think about what we're going to let our u represent, so we're going to let u equal a to the 3rd b. You know what, guys, I'm going to go back for a quick second. So go back to where we just were. So you may not necessarily need to do u substitution for the last one that we just did. If you just factored as normal and did your 120, and then what did we say it was? 8 and 15, that -8 over 6, so -4 over 3 and 5/2. So then you would get 3y minus 4 times 2y plus 5. But notice, right here, I would only get 6y squared. So if I made them each squared, now I have my y to the 4th. So maybe the u substitution is a little bit not as necessary, which makes me go back to this one. Here, u substitution is not going to work, so I don't know why I have factoring by substitution. Because here, if you made your u the middle term, it's not going to quite work out because you don't have a b here and you don't have an a in the last. So let's just factor like we would normally factor. So ignoring all the variables, just do your 15 times 8. 15 times 8 is 120, like in this 120. So 12 and 10 get me 22, but they both need to be negative to get to -22. Put them both over 15. Simplify, so that gets me taking out 3, -4 over 5, taking out 5, -2 over 3. So I would normally get 5a minus 4 and 3a minus 2. But what do I need? I need a to the 6th. Well, 3a to the 3rd times a to the 3rd, adding your exponents gets you a to the 6th. But then I also need a b squared. So that means I need to put a b attached to my 4 and my 2. So b there, and a b here, and then I would have it. So notice in the middle, right here I have -12, a to the 3rd b. Here I have -10, a to the 3rd b, which would combine to make the -22, a to the 3rd b. Okay, so do the u substitution for the ones with the sets of parentheses. That's going to make life a little bit more simpler. These here, just I would factor as normal if it were me, to be honest. And then just make sure that you have your exponents matching up. So if it's a y to the 4th, then you should have a y squared and a y squared. If it's a y to the 6th or an x to the 6th, then you should have 3rd power, 3rd power. Okay? All right, this concludes your notes.